Season's greetings and Cthulhu Fountain, my friends. My name is Alhaz Red, and I'm a professional red teamer / teacher and practitioner of the dark, eldritch magics of hacking. You can typically find me on Twitch doing all kinds of Try Hack Me challenges and general hacking challenges for the benefit of both your education and your entertainment. But today, I'm coming at you with a very special holiday feature and showing you how to tackle Day 9 of Try Hack Me's Advent of Cyber 2022. And we're going to be covering a topic that's, first of all, very cool, and second of all, absolutely crucial to my tool set as a red teamer, and that's pivoting. Now, you might be a little bit overwhelmed by the subject material of this challenge. There is a lot going on. If you've looked at the written prose, the screenshots and explanations of everything that's on the Advent of Cyber page, there's a lot of it. It's very long. A lot of concepts, services, tools, general cosmic madness flying at you from all directions. I'm going to do my absolute best to break down that lunacy for you, make it a little bit simpler for you to understand, and I'm going to do that by focusing mostly on the practical aspects. But please do not feel required to fully understand and internalize every single command that I'm going to show you in this video. First, focus on the high-level concepts of what is going on. Don't get bogged down in the minutia. Don't lose the forest for the trees. I'm going to start by explaining some of those high-level concepts in the interest of facilitating your understanding of them. But if you would like to jump ahead to the challenge walkthrough, I've dropped a timestamp down there in the video description. So, with that in mind, let's talk about pivoting. So what do we actually mean when we say pivot in the context of hacking and cybersecurity? Put simply and broadly, it refers to someone leveraging their access on one host to access other hosts in a different network that would otherwise be inaccessible. Let me break it down to you with an analogy. I'll be using a highly advanced and completely inerrant and infallible piece of software for this to make the visualization just a little bit clearer. So here we are in Microsoft Paint. Now, let's say, for the sake of argument, there's this girl you like. We'll call her Riley, completely arbitrarily, and for absolutely no particular reason whatsoever. Riley is going to be represented with a square over here. Now, technically, someone is going to call this, is going to be in the comments being like, excuse me, Mr. Streamer. That is actually a rectangle. I paused the video and I measured out the sides, and those are not the same length. I don't care. Okay, I don't care. Call it a square, call it a rectangle, call it whatever you want. The point is it's pink. In order to unnecessarily reinforce gender stereotypes. Okay? All right. So it is pink. This is the girl you like. Her name is Riley. Now, Riley goes to a different school from you. Okay? You. Okay, what do you look like? Okay, wait. Now I've messed it up. Okay, there. Like this. You are over here. We will label you you. Perfect. And you are black. Perfect. You're in black. Now, again, Riley goes to a different school, so there's a little bit of a social barrier there. Now, obviously, there's not a physical barrier, not really, but there's a little bit of a social distance. Like, you don't really you tend to not interact with the kids that don't go to your school. Okay? So, really, your only interaction to Riley has been her social media presence. She posts a lot of videos, and honestly, you're a very big fan. She's actually the girl you're referring to when you tell your friends, I have a girlfriend, but you wouldn't know her. She goes to a different school. In truth, you've never even spoken to her. She doesn't even know you exist, but you would really, really like her to. Okay? You want to get it in there. You want to make a new friend. So how can you do it? Well, you have several options, a few of which we'll discuss here. For example, you can slide into those DMs. You can send her an email if you're a boomer, the boomer version of sliding into the DMs. You can just do the classic, tried and true, random friend request out of nowhere and hope she responds. Just maybe don't do it at like 1 or 2 a.m. That might send the wrong message. Or you can do the technique we're going to be talking about for the majority of this video, and you can enlist Johnny's help. So, who is Johnny? So let's represent Johnny here with yet another square/rectangle, if you want to be pedantic. But let's make his rectangle blue, again, to reinforce unnecessary gendered stereotypes. Okay, perfect. Johnny. Excellent. Boys blue, girls pink. That's the way it needs to be. Anyway, it doesn't matter. Okay, listen. Johnny Riley, we get it. So, here's the thing with Johnny. Okay, who's Johnny? Johnny lives down the street from us. You're acquaintances. Not really friends, but you know each other. You communicate. There's groundwork there. Johnny goes to Riley's school, hence why he's on this side of the social divide. He knows Riley. He's our in. And even better, Johnny has a lot of hobbies. He's a bit of a polymath, and you've seen him dabble in all kinds of stuff, like being a doctor, a lawyer, a plumber, a teacher, an astronaut. All kinds of stuff. You have lots of opportunities to get involved in one of those activities and get to know him better. So, to visually represent this, the social wall is a little bit weaker where Johnny is concerned. You have more of a legitimate reason to talk to Johnny. And Johnny is more likely to talk to you back. Okay? So, you pick one of those excuses. Obviously, you pick the astronaut one, and you run into him accidentally on purpose on a trip to Mars or something. Okay? We communicate with Johnny, and you build a rapport. You establish, you have a conversation, you start a new friendship. Maybe you even hang out a few more times. Your stepmom loves him in particular. But you aren't satisfied with just knowing Johnny, right? You want to get over here to Riley. That's the whole point of this. Now, obviously, Johnny's our bro now, okay? We're not disparaging Johnny. The bromance is very much underway with Johnny. But we still do want to get to Riley. So, we get Johnny, we finagle Johnny into maybe introducing us to Riley under some, maybe we just ask him straight up, like, hey, I like this girl. Will you introduce me to her? And he'll be like, bruh, I got you. And he's gonna help us out. Now, we've opened communications with Riley, right? Through Johnny, we can open communications with Riley, and Riley will communicate back to us with Johnny as an intermediary. Maybe we hang out together as friends. Actually, let's make her communications in pink so it's a little bit clearer. And also unnecessarily gendered. Perfect. Maybe we all hang out together and Riley communicates with us, but maybe we build a rapport with Riley now too, and before we know it, Riley is actually communicating back across this social divide with us, and now all of a sudden, we're in there, my friends. We're off to the races, as they say. Okay, so let's take that general scenario that I've just described to you, and let's talk about how it applies to computer security and networking in general. As a red teamer, also known as an adversary simulator, my actual day job is to behave like a real cyber criminal. Compromise their organization like a real attacker would, accessing their sensitive data, taking full control of their networks, ransomwaring their machines, and so on and so forth. Hosts on such a network might be able to access the internet, like they might be able to reach out past their firewall or their router to talk to the internet, but most cannot be connected to directly from the internet. So there are firewalls, there are routers, there's network address translation, or NAT, that's in the way of just talking to random machines on organizations' networks. Back in the early days of the internet, that was much more common, but these days, not really a thing anymore. At least not on the average network, certainly out there. In this scenario, the corporate network, the company's internal network, is the different school that Riley goes to. And Riley, in this scenario, is the sensitive assets of the organization, the domain controllers, the databases, the payment systems, so on and so forth. They're the Riley we want to get to. And they might be able to communicate out to us, although sometimes they will not be able to. Sometimes they'll be on a completely segmented, isolated LAN. But it doesn't really matter. The point is, we need to pivot through other hosts to get to our Rileys. Okay? So how do we overcome these limitations? Well, much like with our silly situation here, there are many options available to us, and you're really only limited, attacker is really only limited by their creativity. But oftentimes it's going to be some manner of social engineering, like phishing, for example. The attacker will send a user on the internal network an email, and if they click it, it somehow grants me access to their machine. So the analogy here the analogous situation here is we slide into Riley's DMs and we hope she responds or clicks on our email, okay? And then that allows us to compromise the rest of the organization from there. But we're not talking about social engineering or phishing. That's beyond beyond the purview of this particular video. So let's talk about one of the other very common options, Johnny. Johnny, in this scenario, Mr. Johnny is any server or host on the internal network of the corporation that is exposed to the internet, such as an on-prem web server or a VPN gateway, or if you're the clients that I pen test sometimes, heck, you're just remote desktop on servers. You're just servers remote desktop. Like listen, having remote desktop open to the wide open internet is still a thing in 2022, people. It's insane. Anyway, point is, Johnny is any software that's exposed to the open internet, software on a server that have vulnerabilities that lead to compromise. A good example is Microsoft Exchange. It feels like every 2 weeks, Microsoft Exchange has another remote code execution 0-day. And Microsoft Exchange must needs be connected to the internet to perform its function of delivering and sending emails. So it's a prime attack surface for attackers looking to establish a beachhead, establish a Johnny, if you will, in the target environment. So they compromise the Exchange server, and then they use the Exchange server to forward their traffic onto the internal network where the Exchange server can communicate with. So we can call that port forwarding or proxying, and we're going to be talking about a lot of that today. That's the way that we can use Johnny to penetrate more deeply into the network and hit Riley's exposed ports. We want to be nmapping Riley's exposed ports, okay? Johnny is great. He's our bro. He's our guy. He's our man, okay? With the bromance, again, is very much underway with Johnny, but he's just not to our tastes. Riley's ports and services are where the good stuff is. That's what high level we're going to be doing today. I'm going to be demonstrating the Johnny and Riley scenario with a command line here just very shortly. Now, we're going to be mentioning a piece of software called Docker for the purposes of this exercise. But if this is your first time encountering Docker, I don't want you to get bogged down in the minutia of what Docker is, okay? It's at a high level, Docker is just a piece of software that lets you run little miniaturized computers that we're going to call containers. Docker in this exercise is being used to simulate sort of an internal network scenario like I've described here in this analogy, where we're going to be compromising one container, one miniature computer, and a Johnny, if you will, and using it to attempt to compromise Riley and maybe other containers that are located around on the internal network as well. We can use Johnny to access all of the machines that he can access on the internal network, okay? And we can even pivot through multiple machines in some cases. We could pivot to this machine and then get to Riley, maybe. if that was necessary. And in some segmented environments, it will be. So that high level is what we're going to be doing today. I hope it makes a little bit more sense now, but that's enough analogies. Let's just hop into the challenge. Let's get started, okay? Okay, so here we are in our browser on Advent of Cyber. We've been doing this for 9 days. This is familiar to you guys by now, okay? For the purposes of this demonstration, I'm going to be using the attack box, which is a virtual machine explicitly for you to attack, try hack me challenges from, that is accessed through a browser-based guacamole session. It's going to be the simplest way that you're going to connect to really any of these challenges. You don't have to worry about having your own virtual machine or VPN connectivity and all that good stuff. So come right up here to this blue box up here, and we're going to click on the little arrow, and we're going to say click on Use Kali Linux. The regular attack box is Ubuntu based. We want the Kali Linux one for this particular challenge. So click on Start Kali Linux, and then click on Start Kali Linux again when it's in the little blue bar, and we'll see that our screen gets bisected here. Now while this is starting up, let's go to day 9, pivoting, dock the halls, and let's click Start Machine. Okay, this is going to start up the machine that we're going to be attacking. This is the machine we're going to be attacking from, and this is the machine we're going to be attacking. Now, both of these need to initialize, and it will take a few minutes for both of them to be up and running, so I'm just going to speed up the video to when they're both ready. Okay, so now we have our Kali Linux machine on the right here, or at least our browser-based guacamole session that's connected to a Kali Linux instance. And we have our Advent of Cyber over here on the right. So let's scroll down. By the way, if you haven't read through all of this, I deeply recommend you at least skim through it. There's a lot of great information in here. We're going to be sticking mostly to the practical aspects here, as I mentioned earlier, just to keep it as simple as possible, because we are throwing a lot at you in this particular challenge. So here we are. We have all the questions that we're going to answer as we go. And let's go ahead and click this little icon up here at the top to open our terminal emulator. Okay? We can go ahead and maximize it. And then we can zoom in here. Control++. That does not work. Let's just click on this a bunch of times. Just trying to make it easier for you guys to see. We'll do it one more time. There we go. That's fine, right? You guys can see. Perfect. All right. So, as we frequently do... Oh, by the way, you're definitely going to want to make a note of your IP address up here. 10.10.116.11 for me. It will be different for you. Make sure you make a note. And don't try to fill in my IP address if you're following along on your own on your own challenge, if you will. So make sure you put in your own IP address and instead of mine. All right, here we go. So we're going to start with our port scan, with our Nmap scan. Okay, so we're going to you've already seen Nmap, so I'm going to use Nmap Tech SC for default scripts, default enumeration scripts, and TAC SV for enumerating versions. We'll do TAC F. That's for a fast scan. Nmap will only scan, I think, the top 100 ports, if I remember right. And we'll do 10.10.116.11. Alrighty, so it will take just a few moments. I'm just going to take a drink of water. Waiting on you, Nmap. There we go. There we go. Our good friend Nmap. And we see that we just have one port open, port 80 TCP. Now, keep in mind, this is only a fast scan. There could be other ports open, but for the sake of this demonstration, we're not going to waste our time scanning for other ports because this is the only port we really need to see. So we see that it is an Apache HTTPD web server, version 2.4.54 on a Debian-based Linux distribution. So it's very likely we are dealing with a Unix-based box here. Another way you can tell that is by pinging the machine. So we can ping. And we do get replies back indicating we have connectivity with the machine. We know that because of the Nmap scan. But what I want to note here is the time to live. A time to live of 64 or less typically indicates a Linux machine. That's because the time to live value is largely set arbitrarily by whatever is being pinged. And in Linux-based boxes or boxes similar to Linux, like Mac OS, tend to set it to 64 by default. Windows will set it to 128. So that's a little tip there for you. Let's go ahead and open up Firefox and browse to this web server and see what's going on over there. All right, so we see a lot of gibberish, lorem ipsum content. This is all just dummy text that web developers will put on their page just to make it look like it's full of content, to see what it's going to look like once it has content, even if they're still building out the structure and don't have any content to put in there yet. But if we scroll down to the bottom, we will notice Laravel version 8.26.1. And we also see PHP version 7.4.30. So what are these things? PHP is a scripting language that's typically used for web applications. So it's typically found on Linux-based machines, although it can run on Windows as well. And you typically see it in web applications. Laravel is a framework that's built on top of PHP so that web developers don't have to code their applications from scratch in PHP. Laravel is easier to build in. It's more extensible. It's better out of the box. You don't have to reinvent the wheel or anything. The wheels are already coming for you. You just have to figure out how to put them on the car, so to speak. And so a lot of web developers will choose to build web applications in these frameworks or even full-blown content management systems or CMSs because we just expect a lot out of the internet these days. We expect fully featured web applications with JavaScript and all kinds of stuff, and that's tough to build from scratch by anyone except for the most dedicated. So most web developers will use frameworks like these just to make their lives easier and also to make their web applications more secure because the coding your own web application is going to introduce a higher probability of bugs. But in this case, since we have an exact software version, in this case Laravel v8, we definitely want to look into that version of the web application and see if there are any known vulnerabilities for it. Okay? So let's just go over here. Back to our terminal. We can minimize this and go back to our terminal here. And we can use, Kali actually has a built-in database of exploits, of publicly known exploits. So we can searchsploit. Searchsploit is how you access it. It's a local database so the internet is not being queried here. It's accessible offline, but it's based on exploitdb.com's database, if you're curious. So we'll just look for Laravel 8 and see what exploits are available for us. And it looks like I spelled Laravel wrong. Mr. Streamer, you should really learn to spell. God, no wonder you people can't get Riley. Christ. Okay, here we are. Laravel 8.4.2. We notice now that the screen is too zoomed in. Okay, I zoomed in too much is what I'm trying to say. But what you would see if this screen was not zoomed in so much is that, and this output was not being truncated, is that it says remote code execution in there. Now, remote code execution is 3 words. That should always stick out to you in this line of work. That means that we can force the web application to execute code on our behalf, which is obviously a very serious vulnerability, especially if it's executed from an unauthenticated context. Now, our Searchsploit database does have a Python-based POC for this, but for the sake of this particular challenge, we're not going to be using that, and we're also not going to be doing it manually. Instead, we're going to be using a whole exploit framework called Metasploit, and we're going to be leveraging its very powerful capabilities throughout this. So to start Metasploit, you can just type MSF console. Okay? So Metasploit is a huge exploitation framework, as we're going to see. It has a lot of capabilities, not all of which are contained in MSF console. There are some Metasploit-based things that are part of the Metasploit framework, but not part of MSF console. But we're going to be dealing with MSF console specifically today. So what is Metasploit, and specifically MSF console? Metasploit, again, it is a modular exploitation framework, meaning it provides a base structure that people can develop exploits for that can be used in an easy and consistent way between the exploits. So one, like, if, for example, if we were to use this Laravel Python exploit, every one of there'll be a lot of POC exploits that you'll find in Searchsploit. You see there's another Python-based exploit, but these are just written by random people, and some of them are better written than others, and some of them they take different arguments. Some of them may have different ways that they want their arguments. Some may be stricter. Like, there's no consistency between exploits. These are hackers we're talking about. But with Metasploit, all exploits are consistently written and interacted with in the same basic way, although they may have different options. And it's constantly being added to, constantly being updated. And it has a lot of other things like scanning modules, auxiliary modules. It has post-exploitation modules. It has a whole bunch of different payloads you can use for all different platforms you can imagine. It has different encoders you can use for those payloads. It has a lot of stuff. Metasploit is far too big a concept to encapsulate completely or to really do justice in just this one video. So I encourage you to familiarize yourself with Metasploit using the information that I'm going to give you in this video, because it is an essential tool for penetration testers to at least know about. You'll often find yourself using it on many assessments if you do get into this line of work. How do we now use Metasploit? Well, we want to see if there is an equivalent of this Laravel debug remote code execution. Again, it would say remote code execution if I wasn't zoomed in so far. The ending of this is being truncated. We want to see if there's a Metasploit version of it. So we can do search. We can search all of Metasploit's modules with the search command, and the keyword we're going to use is Laravel. And I spelled it correctly this time. Splendid. So, again, we're zoomed in very far, so the formatting is kind of messed up, but I think it's more important that you can actually just read the words. We see that there are two exploits that Metasploit has regarding, or at least having Laravel in the name or description. We have, this one is a token, is a deserialization vulnerability. That's not really what we're looking for. But this one, Ignition Laravel Debug RCE, and it's from right around the same time as we saw earlier. So what this may be what we're looking for. So we can actually get information on this exploit by using the info command, and we can either put in the number that's next to it. Like if you search for exploits, they'll each be assigned, the search results will each be assigned a number for ease of seeking more information on them and so on, rather than just having to copy and paste this whole thing in. Or you can either do copy and paste this whole thing, or you can just do info 1. And we'll see what it says. Ignition before 2.5.2, as used in Laravel and other products, allows unauthenticated remote attackers — we love unauthenticated remote code executions, my friends — to execute arbitrary code because of insecure usage of file get contents and file put contents. These are PHP functions, if you're curious. This is exploitable on sites using debug mode with Laravel before 8.4.2. Now, if you remember correctly, going back to our... How do I see Firefox? Firefox again. Is it here? Here we go. Firefox. I'm just trying to see Firefox. There we go. Okay. If you remember, we have Laravel version 8.26. So that likely is covered by this because it says before 8.4.2. Now, we don't know if Laravel debug or this ignition portion of it is enabled at this moment. Ignition is like a advanced error page for debugging in Laravel. It helps you see detailed stack traces and so on to debug your code. It's sort of like, it's just part of the debug mode here. We don't know if that's enabled, but we can actually tell. Metasploit can actually check for us. So first, we're going to say we want to use this exploit. So remember from our search results that this was exploit 1 in our search results. Okay, and we did info 1. So if we want to use a module, we can use 1 in this case. And you see that the name of the module appears in the parentheses here, Laravel Debug RCE. And now we can type info here to see what options it expects. Pretty much all we need right here, all we're concerned about in this particular case is this rhosts function right here. As in, which hosts do we want to target with our exploit? So in this case, this is just going to be your target, your target box that's in your active machine. Mine was 10, 10, 116, 11. We have to do set our hosts, excuse me. Set our hosts 10, 10, 116, 11. I'm sorry that's hard to see. Let's zoom out just a little bit here. Zoom out just a little bit. I feel like I lost the plot a little bit in trying to just really show you. There. Is that a little bit better? Okay. So we can do show options here to see what options the module accepts. These are the basic options. There are advanced options that we're not going to cover in this video. But the only thing you need to change right now is this one, this rhosts. And we're going to use the check command. And Metasploit is going to automatically check to see if the target appears vulnerable. And we see that Metasploit is reporting that our target does indeed appear to be vulnerable.
This is where the fun begins.
This is indeed the beginning of the fun, my friends. Okay. So now we need to talk about two more things before we can really get to the nitty-gritty of the hacking. We need to talk about targets, and we need to talk about payloads. The target is just the underlying operating system, underlying architecture of what you're exploiting. So you can, if you're on a module, you can see what targets it supports by doing show targets. And we can see for this particular exploit, there's one for Unix in memory, meaning it's not going to drop any files to disk or anything. And there's one for Windows, which is also in memory, also doesn't drop any files to disk. As we saw earlier, our box is Unix based. So we don't need to change that because it's already set. Now, as far as payloads, we can also show what payloads are supported by the module by doing show payloads. And you see we get a lot of output with this. There are a lot of payloads that you can potentially use. Don't get too bogged down and overwhelmed by these. These are just various ways of doing the same thing. Most of these are just simple reverse shells. One might be in Python. One might be in Lua. One might be in Ruby. One might be in PHP. One might be in Bash. Some of them are bind shells. Some of them are ICMP-based shells. Some of them are UDP-based shells. All different shells for all different possible scenarios you might run into. We see the default one that it's trying to use is CMD Unix reverse bash. And this is essentially just a bash one-liner, a reverse shell one-liner. This will work just fine for our purposes right now. So all we need to provide for this is this lhost setting. That's local host. Our host is remote hosts, if that was not clear. Lhost is local host. So since this is a reverse shell, our target is going to be connecting back to us. If you refer back to our very helpful and detailed analogy, if I do say so myself, we're basically going to be leaving Johnny a voicemail and saying, hey, call us back on this number so that we can establish communications with Johnny. And we just need to tell Johnny what number to call us back on, right? And this number is just going to be the IP address of our Kali Linux machine. In the attack box, this is going to be the IP address of your ETH0 interface. So we can find that out by doing IPA. And we see that our ETH0 interface has the IP address of 10.10.114.118. Now, Metasploit is actually pretty smart. So if you actually do set localhost ETH0, if you set an interface, if you tell Metasploit, hey, I want to use this interface as my listener, we see that Metasploit will automatically figure out what your IP address is and set that instead. So we can show options. That's just a nice shorthand so you don't have to go looking up your IP address every single time. This is the port to call back on. 4444 is the quintessential classic Metasploit port, so to speak. Basically, all the reverse shells will use this port by default. You can change this if you want. It's not really necessary, though. Not in this particular case. So that's all we really need here, my friends. Before we actually start really hacking here, let's actually just get caught up with these answers over here. We deploy the attached VM and wait a few minutes. What ports are open? There was only port 80, remember? From our Nmap scan. What framework is the web application developed with? Laravel. What CVE is the application vulnerable to? I believe that information is in info. Right down here, CVE 2021-3129. 2021, 31 to 29. Okay? What can and we'll talk about this a little bit later. Okay? Those are all the ones so far. All right? So now we want to run our exploit. So you can, in order to do that, you can either type run, or you could be a super Giga Chad and type exploit and be a super hacker. We're going to do that. Okay? We're going to do that. We're going to type exploit, and we see that it starts a reverse shell listener for us. It sets the check. It checks for the exploit again and finds that it appears to be vulnerable. And we get some of the best words in the English language. Command shell session 1 opened, meaning that Metasploit has received a connection back, and it seems that our exploit has been successful. Okay? Fantastic. We're dropped right into our command shell. So we can just execute a test command here. And we see right away that we can execute commands as the www data user, which means
Hackerman.
We're in. Awesome. Okay, fantastic. So we've hacked our first machine of the day. Spectacular. Johnny. We've established communications with our Johnny. Okay? Remember that, keep it in. I want to keep referring back to this analogy because I deeply want you to understand high level what is happening here, more so than the specific commands that I'm doing to complete the challenge. Okay? So we're going to be referring back to this now and then. Okay? So we can obviously, this command shell lets us execute any raw command we want on the target, but it has some limitations. First of all, it doesn't have the capability to do anything other than just execute raw commands. It can't do anything else by default. We have to make it do stuff. All right. But what if it didn't have to be that way? And also, if this is currently a very unstable, jerry-rigged reverse shell. Any number of things can happen that can cause us to lose our shell here, just lose connectivity with the machine for any reason whatsoever. These are all concerns to us, so what can we do to mitigate it? Well, Metasploit has an answer for us. Metasploit has a special payload called Meterpreter. Now, what is Meterpreter? You can think of Meterpreter as kind of a super shell, if you will. It's a reverse shell, or not necessarily a reverse shell, but it's a payload like a reverse shell that runs on a target, and it allows you to execute commands on the target just like this, but it also has a lot of other built-in functionality. Like, for example, it can upload and download files without the need of anything else to support it. It can inject itself into other processes. It can run Metasploit's post-exploitation modules. It can automatically extract credentials from the target host. It can even turn on a webcam or a mic, as we're going to see. Meterpreter is very powerful, and it's very useful to be in a Meterpreter shell. So we're going to go ahead and upgrade this shell to a Meterpreter shell right now. So the first thing you're going to want to do is type background, which is going to background the shell and bring us back into MSF console. Now, don't worry, the shell isn't gone, and you can see it if you type sessions. Sessions is going to list all current active sessions Metasploit currently has with compromised hosts. And we see that we have one current session, a command shell. We see that this is our IP address, and we're connecting out to 10.10.116.11. All great, okay? Now, how do we upgrade this to a Meterpreter shell? Well, Metasploit's made that really easy for us. We can run the sessions command again and specify the TACU parameter. TACU is in uniform. And then just specify the ID of the session we'd like to upgrade. Okay, and then we hit enter. All right, so it's starting a new reverse shell handler. And it's going to run some commands here. And we get Meterpreter session 2 opened. Spectacular. Now, we can check that with the sessions command again. And we see that now we have 2 sessions. now we have 2 sessions, okay? We have a Meterpreter shell, which is session 2, and we have just our regular command shell. And we see the Meterpreter shell also returns interesting things like what username we're currently running as, and the internal IP address of the host, which is useful information for remembering which session is which when you have a number of these sessions open. Okay? So, how do we now interact with our new super shell, our new Meterpreter shell? We can do sessions, tac I for interact, and the name of and the ID of the session, which is 2. We hit 2, and now we're inside Meterpreter. Now, you can list all of the available commands to you by typing help. As you can see, the Meterpreter has a lot of built-in functionality. I deeply recommend we don't even have close to enough time to go through even half of these commands. I deeply recommend you to take some time, play around in Meterpreter a little bit. Meterpreter is very powerful and very useful. I deeply recommend you familiarize yourself with it. You can even, as I said, you can turn on a webcam and a mic by doing this. You can play audio files on the target system, which is kind of funny. All kinds of stuff here. We're going to be using several of these commands, but not all of them. Go through these, get an idea of what Meterpreter can do. So purely for an example, if you type get UID, that's going to get your username. It's a little bit like who am I? And you can do get PID to see what process we're in. We're in process number 34. And you could type PS to get a list of processes. Now, if you've ever seen a list of Linux processes, like on a virtual machine even, and on any Linux machine, chances are there were a lot more processes than this. This is indicating that we are in a Docker container. You can also tell with the .docker env. Again, if this is the first time you're hearing about Docker, please don't be concerned about what Docker is at this point. Just understand that this, our Johnny machine, according to our analogy, is a kind of miniature computer that's really just designed to run Apache and nothing else. That's why there's so few processes, and as you're going to find, there are a lot of commands that are typically found on Linux machines are not available on Docker containers because they only have the bare minimum needed to run whatever application they're trying to run. Okay? So, what can we do from inside of this Docker container? Well, we, as penetration testers, what we often want is credentials, okay? And inside Docker containers, credentials are often found in a couple of places. And in order to show you, we should probably drop into a command shell. Meterpreter has a shell command that it will start a new bash or a new process of whatever the default user shell is. I think it's actually dash on this one. But you can see that we do have a command shell here. One nice thing about this is that if this shell dies for any reason, this is just like our other shell now. But if this shell dies for any reason, it's just going to drop us right back into Meterpreter. Meterpreter is not going to die. It's going to be persistent on the host, and as long as the process is still running, it's going to try to connect back to us. So Meterpreter is a lot more stable than just these individual command shells. That's another benefit that Meterpreter has. So we want to think about where can we probably find credentials. Well, the purpose of this container is to run Apache. Web servers often have to store credentials. Typically, they store user credentials in databases, and they need credentials to access the database as well. So we need to find the database credentials that will allow us to potentially access the database and extract even more credentials from them. There's a couple of places these will likely be. In Docker containers, in my personal experience in real life, you often find interesting information in the environment variables. So type env. We see that we don't have any interesting environment variables in our current process, but if we wander on over to var dub and we list in here, we see there's this .env file here that defines a set of environment variables for Laravel to run with. So we can take a look at what environment variables is Laravel running. Oh, we see quite a few here. Quite a few. One thing you're typically looking for is like API tokens and stuff and so on and so forth in these Docker containers, at least in real life. But in this case, I want you to focus on these credentials right here. Remember I said we want to access the database. Okay, we want to access the database. And we see that there is a database at domain name web service database _ database. and that the database name is Postgres, the username is Postgres, and the password is Postgres. A very secure set of credentials right there. I never could have guessed that. Really glad we found this. But you might wonder, where is web service database located? We don't know where that is. What IP address is that located at? Well, Meterpreter can help us out with that. We can exit out of our shell here, and we can use the resolve command to use the box's DNS server to resolve this domain name. And we see that it resolves to an IP address, 172.28.101.51. Perfect. Make sure you copy that down. We're going to be using it again here in just a moment. Now, going back into a command shell here, dropping back into our command shell, we're going to find that we actually don't have the IP command. We don't have ifconfig. We don't have a lot of the commands that a normal Linux machine would have, because again, we are inside of a container. However, knowing what I do about containers, I know that typically the host, as in the host that's actually running these containers, there is one actual machine that's running all these little fake containers. And that host is typically located at IP address 172.17.0.1, at least relative to the container. So we can try and ping this. I don't think ping is present, but we can try it anyways. Okay, yeah, there's no ping. Take it from me that this is a fairly, this is an extremely likely thing to happen. Unless the container creator has for some reason changed all the IP addresses, the host is usually situated as the gateway for all the Docker containers, and it's located at this particular IP address, okay? Just take it from me. I do this stuff for a living, okay? Very, very common. We have two IP addresses of interest. We have the Postgres database, and we have what is likely to be the host. Now, both of these can only be accessed from the Docker container. Like, if we were to, for example, ping this, if we were to copy selection, we open a new... What did I just do? I just cleared the terminal. Okay, at least we didn't... All right, whatever. All right, I just... Listen, I know how to use computers. I know it. Wait, stop. I can hear you people through the screen right now. Shut up. All right, we're going to click on new tab properly as if I know how a computer works. There we go. We're going to zoom in a little bit so that you people can see, okay? And we're going to try to ping this IP address.
Can't let you do that, Starmark.
So we can't reach it. Ping is not getting any replies. This is an internal IP address. We're not able to reach it from our Kali machine. And I could demonstrate that we can reach it from this host, but of course, ping is not present. We now want to leverage our access to Johnny to access other hosts on the network. We have two other hosts on the network, two other Rileys, if you will. One is the likely host, the actual host that has the Docker containers on it, which is where we want to end up, by the way. We want to compromise the actual machine that is running these containers, not the containers. And we also want to access the Postgres database because it could have sensitive information in it, such as user credentials. Okay? So keep that in mind as we go here. We have a couple of ways of doing this. We could upload a bunch of tools like statically compiled versions of Nmap and ping and all of these tools that we could use onto this container and just operate entirely from the container. But that's a little sloppy, right? We have to upload all those files to the container. If we have to remember to remove those later. It takes a while. It's the statically compiled versions may not work for some reason. There's a lot of things that can go wrong with that. It's a lot easier to just use Johnny to pivot, to proxy our traffic. As in, we're going to send traffic from Kali, but we're going to have Metasploit route it through Johnny to reach these other two hosts, the Postgres database and the target host that we're actually trying to reach, okay? We're going to use, going back to our analogy, we're going to use Metasploit to send traffic to Johnny and have Johnny send that traffic to Riley. Right? Hopefully everyone understands that. So this is where the actual pivoting starts. Like 50 minutes into the video. There's a lot going on in this one, okay? Listen, it's not my fault. Don't type exit. Exit's bad. Type background. Oh, no, exit. You actually do want to type exit because we're in a Meterpreter shell. So we're going to type exit. We're back to Meterpreter. And then we type background. We background session 2. And we're back in Metasploit again. Now, first we need to set up our port forwarding or our pivoting. Okay? And the way we can do that in Metasploit is by using routes. Okay? So we're going to do the route command. And you can type route tac h if you want to see all of the options here. Add, remove, get, flush, print to print all the routes. Like if we do route print, it's not going to show anything right now. No routes defined. We're going to define some routes. Now, what do we mean by defining some routes? We mean we're going to say, hey, Metasploit, I'm going to give you an IP address. And whenever I send traffic, or an IP address or a subnet, and whenever I send traffic to that IP address or that subnet, I want you to send it through a currently active session that I'm going to define for you. As in a Johnny. I'm going to have you send it through a Johnny. So root add, and we're going to put in our Postgres. If you go, I mean, I can't look back up. I accidentally cleared the terminal. But I wrote it down, thankfully. 172.28.101.51. Remember, this is the location of the Postgres database that the web server is using. And then we need to add a CIDR of 32. If you don't understand subnetting, that's okay. Don't worry about this. All you really need to know is that /32 means that this isn't really a subnet that we're defining. It's a subnet of a single IP address. We're defining one single IP address here. Like if we were to put, there are some examples up here. Like you see this one ends in /24. That's because it's a subnet with 255 distinct IP addresses. I guess technically 256, but I'm not going to get into subnetting right now. Defined by this last IP octet. Don't worry about that right now. Just know that we're only adding single IP addresses here and not subnets. So /32 is appropriate. And then we're going to put session 2 to pivot to route it through our Meterpreter shell. Okay? Route is added for that one. And then we have another IP address, right? 172.17.0.1. That is what we expect is Riley, is actually Riley, the host that's running all these containers that we want to actually compromise. We want to compromise the host. So route add 172.17.0.1. Again, with the /32, because this is just a single IP address and not a subnet. And we add a 2 to route that through session 2, the Meterpreter session as well. Okay? So now we can do root print just to double check our work. And we see that we have two IP, that whenever traffic is sent from Metasploit to this IP address, Metasploit is going to automatically send it through this session. And whenever it sends it to this IP address, it's going to send it through this session as well. Okay? Hopefully that makes sense. Now, again, we have credentials for the database, right? So it stands to reason that now we should try and access the database. Okay? So Metasploit actually has some additional modules that can help us with that. So we can search Postgres. Search for any modules related to a Postgres database. Now, again, we are zoomed in quite a bit here, and there are a lot of them that you can go through here. You can feel free to experiment with these if you feel so inclined. The one we're going to be using first is this one right here, schema dump. The Postgres schema dump, this is just going to dump basic information about the Postgres database, as in the names of the database, the names of all the tables in the database, the names of all the columns in the tables, and so on. It's basically going to give us hints of what we want to access in the database. So we can go use 16. Remember, you can do use 16 in this case, or just copy and paste this whole name if you want. Like that. Now we see Postgres schema dump as our currently active module. And we can do info. And we see this module extracts the schema information from a Postgres server. Spectacular. So what we need to add here is the R host. We need to change all this information as appropriate. So we set remote host. And remember, our Postgres database is 172 28.101.51. Okay. Show options. I like to do show options every time I change something just to make sure I said it correctly. The database is going to be Postgres, and you can remember this if you go back and look at the database information we looked at in those environment variables for Laravel. We see the database name was Postgres, the password was Postgres, and the username was Postgres. The port is also identical, so you don't have to worry about changing that. You don't have to change any of these, honestly. All of these other than the rhost should be fine. Now remember, we can't reach this IP address directly. Metasploit has a route added. We've added a route to Metasploit to tell it, hey, when you see this IP address, we want you to contact it through a currently active session that we have. So remember that. That's how we're doing this. And now we can type exploit because we're GigaChad Ultra Gibson hackers. There we go. And we see that we successfully have extracted the schema. We've accessed the Postgres database. These are useless to us, but this one is not. We see that there is a table called users, which has a username and a password column. Spectacular. We definitely want to see that. Those sound like they're going to be
a fine addition to my collection.
We're always looking for more credentials to add to our collection, right? Okay, so let's the schema dump cannot dump the contents of this database, but there are other modules that can. So let's search Postgres again. And let's go, I think this one. Postgres server generic query should work just fine for us. All we want to do is execute a raw SQL query against the Postgres database, and that'll dump the required database. So we can use 11. I guess I'll do it the other way just to show you it's possible. So we can use paste. It looks like I messed it up. Use paste clipboard. There we go. Alrighty. So now we're in a different module for Postgres. We're going to execute a SQL command against Postgres. So info. This module will allow for simple SQL statements to be executed against a Postgres instance given the appropriate credentials. So let's make sure we set all of our options correctly. So we set our hosts first to the IP address of our database, 28.101.51. Okay, and now we have to set a couple of other things. We see the username and password is set correctly, but this database is not set correctly. We want the Postgres database. So set database Postgres. And again, refer back to the environment variables in Laravel, and you'll see that the name of the database is Postgres. All right, and we see that the default SQL statement that it's going to execute is just select version. So it's going to get the SQL database version. So we type exploit. We correctly get the Postgres database version. Spectacular. So now we just need to modify the SQL query that we're executing. So we're going to set SQL select star from users. We're basically just telling Postgres, hey, retrieve all information from the users table for us. Okay? Select star from users. We run. Ah, that is just splendid. We see there's only one row in this database, but it appears that we have some credentials, some
fine addition to my collection.
Some new credentials to add to our collection. We always love more credentials. Okay, we always love credentials. Copy selection. We're going to paste this. I'm going to paste this into my notes off screen over here so that I can refer to them. All right, so we have credentials. Now what? Now what can we do? Well, we need to talk about how we're going to talk to actual Riley. All this time with the Postgres database, we've been talking to one of these, to another container. The Postgres database is probably running on another container. We've probably already extracted all we need from it, to be perfectly honest with you. Now we want to get to the host. We want to get here. We want to finally get to Riley. So in order to do that, we need to we need to scan Riley's ports. We need to see what ports Riley has exposed. Riley's ports are what's really interesting to us in all of this. Okay? So, how can we do that? Well, we can use Metasploit to set up what's called a SOCKS proxy. Okay? A SOCKS proxy is going to allow us to send traffic just from our Kali command line over here through Metasploit. Metasploit is going to automatically route our traffic through Johnny for us and to Riley. Obviously, I've shown you how to run auxiliary modules with Metasploit, and you can do a port scan of Riley this way. But I think it's more valuable to show you that Metasploit also has a SOCKS feature, since the focus in this module is on pivoting. And I want to show you as many functions related to that as possible. So if we search SOCKS, we see that Metasploit has an auxiliary module called SOCKS proxy. Okay? So we can use 0, and we can get some info on that module. This module provides a SOCKS proxy server that uses the built-in Metasploit routing to relay connections. So it's going to use our routes. It's setting up a SOCKS proxy that allows that the rest of our Kali machine, like our other terminal over here, can use, and it's going to route traffic based on the routes that we added. So if we remind ourselves what those are, these are the routes we currently have added. So if we want to route traffic to these hosts, like from Nmap in our terminal or something, we can use Metasploit as a proxy using this module. Okay? So let's go show options and see if we need to change anything. SOCKS version 5 will work just fine. I like to use port 1080 for my SOCKS proxy. You can use whatever port you want. Just make sure you make a note of it, because we're going to need it here in a second. And that's about it. You can just run it. Just run it. There we go. So you can see that it's running with jobs. All jobs that are running in the background can be accessed with the jobs command. They can be killed with jobs tac k. Like if you wanted to kill your SOCKS proxy, it'd be jobs tac k1. But don't worry about that now. We want it running. So Metasploit is now a SOCKS 5 proxy. You can use SOCKS 5 or 4a. It doesn't matter for the purposes of this exercise. I just like using SOCKS 5. It's a little bit more versatile, but we're not going to go into it right now. In order to route it, we can try to use curl through the proxy first, okay? Curl, I believe, can use it with tac proxy, and we just need to specify SOCKS5://127001 for localhost, because, again, Metasploit is listening on localhost port 1080. This is where our proxy is listening. In the module that we just set up, it's on localhost port 1080. And then we're going to contact port 172. We're going to contact Riley on port 172.17.0.1. Okay? And we see, alas, we can access a web server on 172.17.0.1. Splendid. And just to demonstrate to you that the SOCKS proxy is routing that, if we just try to curl that IP address, we get nothing, because this is an internal IP address and Kali doesn't know how to reach it. But it does if we're telling Kali, hey, Metasploit is listening with a SOCKS 5 proxy at localhost on port 1080. Go there, and Metasploit is redirecting our traffic accordingly through Johnny, through session 2, remember, to hit Riley. Really cool stuff, right? Really, really neat stuff there. And we can take it even a step further and use a tool called proxy chains. Proxy chains essentially allows you to use a proxy with just about any Linux command you can imagine. The first thing you need to do is change your etc proxychains.conf file. Scroll all the way down to the bottom where you're going to define the proxies. In our case, we defined a SOCKS 5 proxy. So I'm going to change that to SOCKS 5. And instead of 9050, I'm going to use 1080, because that's the port my proxy is running on. You can also, as indicated by the name proxy chains, you can have multiple proxies in a chain here that proxy chains will all handle completely transparently to you. In this case, we just have the one proxy. So just make sure you get a SOCKS 5 one in there. Whatever settings you put on your Metasploit proxy with the correct port, the proxy type, and all that, just make sure all that's correct. Okay, so now if we preface any command with proxy chains, like if we do proxy chains curl http://172 17.0.1. We now say we get a response with curl again, because proxy chains is taking curl's traffic and routing it through Metasploit in the exact same way as curl was doing it before. Okay? We can also use an nmap scan with this. So we can nmap, we could do TAC-F for a fast scan, TAC-SV for enumerating versions, 172. Oh, we also have to do TAC-ST for a full TCP scan, or it's going to behave strangely through a proxy, and TAC-PN. ICMP traffic cannot go through proxy chains. So you need to turn off nmap's ping in order to use it. So 10, or it's going to be 172.17.0.1. Okay, you're going to see a lot of output here. Proxy chains is very verbose. It tells you about every connection it makes. It is scanning. Nmap is scanning. Hopefully it'll be done here in a moment. Maybe I shouldn't have done the TAC-SV. Okay, let's just do it again without the TAC-SV. Okay? Scans through proxies are predictably going to take a little bit longer. So let's, for the sake of the video, let's just remove that. Our box didn't die on us or anything, did it? What's happening here? Socket error or timeout? Nope, our box is still live. What's happening? Something wrong over here? Sessions? Nope. We still got a sessions. Our sessions. Sessions TAC I 2. Get UID. Uh-oh. It looks like we may have lost our interpreter shell. It's not communicating with us at the moment. Of course not. I'm recording. Why would it work? Operation timed out. Stupendous. Background. Do we still have this session? We still have this session. Okay. The box is still working. There's just something wrong with our interpreter shell. Okay, we'll do. All right, I'm gonna pause the video. I'm just gonna kill our interpreter shell, start a new interpreter shell, and then change all the routing. So I'm gonna fast forward the video to when that happens. Okay, we're back. All right. Of course it does that while I'm recording. I don't know what that was. I started a new interpreter shell. I reset all of the, which started in session 3. I reset all the routes. And now we can properly nmap scan Riley, the host, 172.17.0.1. And we see that there's this port, this SSH port is open that we never saw before. And also this port 80, which we were curling. So with SSH, the important thing to remember is that we have Santa's credentials, right? We got them from the Postgres database. So what do you guys think the chances are that Santi is using the same password for both the Laravel web server and for SSH? Surely nobody would be so incompetent as to use the same password for two different services. Listen, the man's got like a million elves to keep track of, and he's making toys at like round the clock presumably, and then he's got to do the most ridiculous delivery service that puts Amazon Prime to absolute shame, like into the dumpster for speed and efficiency in one night of the year. The man's got more important stuff to worry about than what passwords he's using. So naturally, he's going to reuse a few. That makes perfect sense. Please, half of you watching this video probably use the same damn password for everything online. Don't bullshit me, chat. Okay? Or not chat, as I would refer to on stream. Viewers, YouTube viewers. Okay. So, Metasploit has a way we can SSH. You can obviously just SSH from here using proxy chains if you want to. But Metasploit has a module that will log into SSH for us and start a new session, a new command session or a interpreter session or whatever we want to start. So we can search SSH. I think it's _login. Perfect. So this one right here, 0, use 0, And we see we're in the SSH login module. We can get info. This module will test SSH logins on a range of machines and report successful logins. If you've loaded a database plugin and connect to a database, this module will record successful logins and hosts so you can track your access. So this module is very versatile. It can be used for brute forcing with or password spraying with a lot of usernames, a password file or username file, or usernames and passwords in a single file. You can attack a lot of hosts with it if you want. You can try and spray a lot of hosts. Very versatile. In this case, we're just going to be attacking a single one. So set username Santa. Set password. Password. A very strong password. And we're going to set our hosts, and that's Riley's IP address, remember? Our hosts is 172. Set our hosts 172.17.0.1. And that should be all we need. But if you want, you can play around with the payloads. If you want, you can look through. As you can see, there's an awful lot of them. 950 possible payloads that you could be using. But a lot of these for Windows. So obviously those aren't going to work, but whatever. All right, so we're going to run this payload. Whatever the default payload is should work just fine. We see that we get a successful login. So Santa has reused his password. Big shock. I, for one, am stunned as a cybersecurity professional that anybody would use the same password for more than one service. And then we can check sessions, and we see we now have a fourth session, SSH as the root user, and we can sessions tac I root, or not root, 4. Okay, ID, we are root. And if we ls tac la the root directory, we see that there is no docker env file, indicating that this is very likely to be the host. We have finally made it to Riley. Riley is our friend now. We've done it. Well done, friends. All right, let's go ahead and fill in all those answers that I've neglected up until now. What command can be used to upgrade the last opened session to a meterpreter session? So sessions tac I, or sessions tac U, and I think it's actually tac L for the last opened session. No. Is it tac 1? There we go. Sessions tac U tac 1. What file indicates a session has been opened within a Docker container? That's going to be, if you recall, the .docker env file. Okay? That's going to be in the root directory. What file often contains useful credentials for web applications? .env. If you remember, in the var www folder on Johnny, on the Johnny server, according to our very helpful and well thought out analogy, infallible, if I might say, the .env file contained the database credentials and the locations of the database as well. What database table contains useful credentials? That was the users table, very common. All right, what is Santa's password? That was P4 $$ W0RD, a very strong password, tremendous. What ports are open on the host machine? We had 22 and 80. And what is the root flag? You can simply copy it out of here. I think you have to do this craziness with this clipboard. Okay. And we can copy it here. Paste it in here. Submit. And we've completed this challenge of Try Hack Me Advent of Cyber Day 9. So that's all I have for you today, my friends. I'm sorry this video is so long. This challenge really hits you with a ton of new concepts and information all at once, and it was difficult to cover it all while also explaining things at a high level and to a reasonable degree such that I felt a beginner could easily grasp it, particularly like the networking pieces, which are the whole crux of the module. If you have questions, feel free to drop them in the comments below and I will answer. You should also feel free to reach out to me on Discord for any questions, comments, feedback, threats, bribes, whatever you got. If you liked what you saw, I encourage you to like the video and subscribe to the channel. It helps me out more than you can possibly imagine as a content creator. Better yet, check me out on Twitch at twitch.tv/allhasred. I stream there 3 times a week, doing all kinds of cybersecurity challenges and dropping all manner of eldritch, esoteric hacking wisdom. We also have a lot of fun slinging memes back and forth on the reg in there, too. It's a good time. Cthulhu fhtagn, happy holidays. Good luck with the rest of Advent of Cyber. And I'll see you guys again when the stars are right. Have a good one.